So actually, as per the main topic of this practice today is talking about the pointers only. We are going to go step by step, and we'll manipulate the pointers from different views, from different perspectives. We'll interpret them differently, and we see how to utilize the pointers. We will manipulate the pointers in different circumstances and different scenarios. So let's just dig in and let's go step by step. Task number one is asking us to just simply initialize an variable and display its address. We will understand that just right away. So my online compiler, the cpp.sh. Yes, it is taking too much time, but even though, okay, I'll take out this one. I do not need a string. I need the to call my namespace. Good. In here, let's just do whatever he's asking us. He's asking us to just declare an int, and this int, for example, it is not initialized so far. Just see, I'm gonna just bring an output of this int as we discussed today morning in the theory, and immediately I'm gonna just display the result. See, it is not initialized. Let's see what would be the output. He's not expected to reload, but he's doing the reload. I'm just okay. He brought to me 0 because it's an empty. He did not give me an error. He did not give me an error. What I'm gonna say, just I'll try to call the address. I'll try to call the address here. So you actually know this is an annotation. This address here. Let me maximize the view. This is an annotation that we defined with the pointers only. We did not have the habit to call this ampersand with a simple variable. Let's just see. Nothing is there. So he's waiting for me to input something. Enter. He's waiting for me to input something. Nothing actually. It's not actually. I'm just referring that this thing actually is an open entry. No more, no less. It's not giving me the address. What I'm gonna do. I'm gonna just change this a into an array. See here, it's an empty array so far. I did not specify the size, and I'm bringing the output of this a only without indicating that it is an array. Still, I'm trying to search to find a way to display the address without the pointer, without specifying that it is a pointer only. It's taking too much time because of this problem here. I'll give him just a few seconds, otherwise I'll interrupt that. Okay, just I'll interrupt that. I'm going to change something here. I'm going to just give a size, for example, 10 cells, and I'll execute again. To make it more punctual. See out A. What is this A? Not initialized. So also I'm going to give it a few seconds, and I'll interrupt. Okay, I'll interrupt. It did not give us an result. See what I'm gonna just initialize now this area. I'm gonna say, okay, just let me here and let's say 0. They are 10 now, 10 numbers, so 10 positions, and they are 10. Those are 10 values. Okay, let's just run again. Yes, it given me, see here. What is this thing here? Something strange. This is actually an address in memory. It's a location in memory, and specifically it is the address, as we discussed, it's the address of the first value. Is the address of the first value. Specifically, exactly what this task is asking us. But still, we are going to manipulate this thing here in a different way. See what I'm going to do now. I'm going to just call cout. Here I'm going to say yes, the address of a position 0. I'm going to just call the end of line, just one, and I'll see what it would do. See the result here. See the result here. So I'm going to just make it the thing more specific. Address of the array. I'm going to say the address of the array. Okay. Also, I'm going to add a string here to make it more clear for us. The address of the first element of the array. That's good. Colon space, colon space, 1. Address of the array. This is it. Address of the first element of the array. This is the same value. If you compare it here, it's the same value. So we have a proof. Now the address of the array is not the full arrays. Is the address of the first element. See, I'm going to search for the address of, for example, this is the fifth element, number 5. I'm going to say 5. Search. It is something different. It is not the same. It is not the same. So here we have a proof that the address of the array is the address of the first element. And here we are just bringing an address of an element. But here it's an array. Remember, this is an array. This is not a normal variable. I'm going to just declare an int, let's say b here. It's a simple int, and I'm going to initialize. I'm not going to initialize first of all. So remember that we had an issue at the beginning, bringing out cout the address of b and an end of line. Good. See here, address of b. Let's see the result. It gave us the address of the b, but it's not the same. Yes, it's not the same. Here actually is the first A and yes, first position. So perfectly. Those are the same, and this is actually a different address. It's the B only. The int address is simple like that. So very good. Very good. Yes, absolutely true. So we are actually having the thing in a clear and a very clear and neat way. Now we have actually a good understanding. I did not initialize the b, huh? The b is not initialized yet. I'm going to initialize, for example, with the value, let's say 100. It's an int 1. The same address. It's the same value if you notice very well. Double diff 786C. It's not the same address, but even though it is an allocation in memory. So here, remember, we do not have to have the same values every time, but in this case they have to be the same, those two. If this one is address number 1, this has to be the same address. Why? Because they are pointing at the same address. But in your computer you'll not find the same results. Those are locations in memory, so it depends on your computer and depends on the time of the execution only. So but it is an address only, no more no less. So because of this is changed. Again, it has been changed. So it is a location memory that has been allocated, but it's not the same time. It's the same at every time. Very good, very good. So this way we were able to initialize. Come on, initialize an variable as an integer, and display its address in the memory. No more, no less. Very simple here. Good. Before I pass to task number two, just let's have a small briefing on using the arrays as a pointer. So in the same program, I'm gonna just keep this one here, and I'm gonna open a second interface. Yes, and I'm gonna bring some modifications here. Yeah, so good. I do not need this thing. I do not need the B also, only the area I need. Good. So the first value, let's say, the first element of the array is not the address here. That's one. The first element of the array, 1. Position 0. Position 0 is 1. True. Let's say the last, the number 10. There are 10 positions, no? I'm calling the number 10. This is an error. This is an error. But let's see. It's 0 because we are reading at position 10 and we do not have position 10. We have position 9 starting from 0. 1, 2, 3, 4, 5, 6th, 7th, 8th, and 9th position. So here the position number 9. Let's run. It would be 0. Yes, it is 0 only. Position number 8. Let's say, for example, it displays everything actually. Number 9. That's good. That's good. So let's just write another statement here. See what I'm gonna type. See out. Less than. I'm gonna say A. I'm gonna say A. Yes. Less than. And L. This one would display actually the address. The address. Absolutely, it is the address. I'm gonna change it a little bit. I'm gonna say this is the address, but I need to display the position number 1. Okay. And since I'm gonna talk about the content, I'm gonna specify that it is the content here using the star, the asterisk. The asterisk here at the beginning. So to say that I'm bringing the content, not the address. Let's just compile that. Yes, position number 1, 0, 1, 2. Here it is. Perfect display. Let's say position number 10 means index number 9. Number 9. It is 0. Perfect. Let's say position number 8, like this one here. So it has, if I'm right here, it has to display the same result 9. Let's compile. It is 9 only. It is 9 only. So perfectly, it works very fine in the same way. So let me just bring this message also here. The first element of the array. Let's say not the first element. The value of the array. The value using an array is the value. Changing the string only using a pointer is. The values in a pointer is 9. So it works very fine. It works very fine. So this way I'm using a pointer to display the thing while I did not initialize. I did not initialize here. It's another syntax dealing with an array. So the area already it is actually defining a pointer in the memory. Points to this value, the first value, and then after to the second, to the third, and so on. Those are the values fulfilling the areas allocated by this array in the memory. Good. This is the context of the just display here to display the content. Simply, I'm gonna refer to a simple, let's say, for loop. For loop, I'm gonna say I'm gonna just start from the 0, and I'm gonna say for loop int I equal, and this I is less than strict 10. I plus plus incrementation. Okay, here in between, I'm gonna pass through. I'll start with the. I'll just display the thing. I'll just display the content of the array. So see out. Less than. The array value at quotation less than. I'm gonna say here I less than is okay less than a position I less than and L an end of line. Good, great, simple. I'm gonna just see phrase the same thing here. The value, the point of the array, let's say the value using an array using a pointer, not an array, at I is how to change it. So two simple parentheses, the name of the array plus what I, the counter, and then before the parentheses, the asterisk, the star. That's it. Okay, those are two statements. Statement number one, statement number two. They belong, both of them, to this for. So I have to start here with a curly brace, and I have to close it here. Great. Let me just run now. Okay, here at the beginning, the first element is 9. The value is using a pointer is 9. Those are the two strings here. Later on, here, the value using a pointer at 0 is 1. The value at 1 is 2. Those are the values here. Those are those are the messages here only. So it is repeated. Let's say loop 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed it. Yes, here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They are 10 values. All of them, they are being read. 1, 1, 2, 2, 3, 3, 4, 4, and so on. So it is really, it is bringing us the output, but using different syntaxes. Here using a pointer, he's using a simple area indicator. Okay, I'm gonna now I'll leave this static initialization of this array, and I'm gonna leave this one also as well, and I'm gonna pass, just leave it a little bit again, leave this space here, and I'm gonna re-initialize this array, but in a dynamic way. So I'm gonna, since I have an iteration, loop is my solution, my friend. So here I'm gonna redeclare the I again, int I equals 0, I less than strict 10, and I plus plus incrementation. So I'm gonna start a curly brace to avoid any conflict here. Yes, and let's do the thing here. Actually, I'm gonna enter. I'm gonna just display a message to indicate that enter the value number less than, let's say here I, and offline. Okay, here scene, I'm reading. I'm gonna say A at position I. Simple. This is the first solution, no more no less. That's it. It's enough for me. For me now, actually, I'm gonna just be grateful. So here, enter the position 0. I'm gonna say 1, position 1. I'm gonna say 2, position 2. I'm gonna say 3, position 4. Whatever. خلاص. I have put some numbers. That's it. It's enough. So later on, he displayed the thing for me. So it worked without any errors. I'm gonna make a second way. So this one I'm gonna change it to a command. So to cancel that one, and I'm gonna just give a second way how to initialize dynamically the area at the position I. So A plus I, but here it's a content. So asterisk semicolon. Let's see if it works or not. If it gives us the same thing actually. Enter the value of the value number. Here's 0. He's waiting for me to input. I'm gonna say 1. Enter. It went. Enter the value number 1. I'm gonna say 2. It went number 2, and so on. So it works very fine. It works very fine. It's the same. It gives us the same result. Either we type this way. Let me stop. Either means we type this way, the regular array indication, or using a pointer here. But we have to respect the syntax. No more, no less. Let's just execute that and have a result. command, and let's use this technique, the pointer. So let me stop first. I do not need those things here. Change them to commands. Okay, run. Okay, enter the value number 0. I'm gonna say whatever, for example 0. Value 1 I'm gonna say 9. Value 2 I'm gonna say 8. Value 3 I'm gonna say 7. 4, 6, 5, 4, 3, 2, 1. That's it. And then after he displayed all the output using this the second loop, this loop here. So after reading, he inputted the new values. The first value is 0 because I inputted 0. Sorry, I inputted 0 here. The second value is 9 because I inputted 9. It's not the second value here 2. It's the one I inputted here. So the one that has been displayed in output. And consecutively, he inputted all the values I inputted. 9, then 8, then 7, then 6, and so on. The value that I inputted dynamically, he is displaying. So this way actually we are manipulating actually an array, a variable content which is an array. We know how to display its address and the address of the first element and the address of every element inside the array. And we know how to manipulate the array as a pointer and to use the pointers to manipulate the array elements, whether by display or to display or to initialize to input. Task number 2. Create a C++ program to initialize an integer variable to display its value and its address and the memory, both. Simple. A new interface. So I don't need this thing. Neither this thing. I'm gonna call my library. Okay. Using namespace as good. Here, I'm gonna inside the main only. I'm gonna declare an let's say var, and I'm gonna display its let's say starting its address. I'm gonna say another line. Okay, let me execute. He's saying just 0 only because it's not initialized, it's not being utilized so far. Okay, I'm gonna just change that into a simple initialization now. End var, cout var. I'm gonna give a value. He gave me the value itself. So he's not giving me the address. So what should I do? Simple. Address. This is the address of the variable. The same way I'm gonna say here a string. Let me just clarify that. The variable address is the variable value is okay. The variable address is, the variable value is. Perfectly working fine. That's perfect. That's perfect. That's perfect. But using a variable here. See what I'm gonna do now. I'm gonna declare a pointer. And a pointer, to be a pointer, I have to use the star. Here's the star as an indicator. Okay, I'm gonna just do the same 2 phrases here. Okay, the pointer address is the pointer. So I'm gonna write here ptr, and the pointer value is also, I'm gonna type here ptr. Let me run. We need the pointer content and the pointer address 1, 0, and 0. Actually, because we are on an online compiler, so it's not the same messages we would have actually when we are developing in a local installed software like Visual Studio or something like that. So Visual C++ or something like Visual Studio, whatever the dedicated applications, computer programs installed in an on-premise computer. So it's not the same output. It will give us actually a fatal error here because it is not initialized. It is not displaying the address. It is not displaying the value of the pointer. So what should I do? The address, simply, this is a pointer, no? This is a pointer. So the same commercial end. Run. The address, here it is. He's giving me the address of the pointer. It's not the address of the variable. This is a completely different address. Then the value. Here actually I need the content. So star. The star pointer. Run. Still here is not displaying anything. This is the fatal error. This is the fatal error here, but it's not displaying anything here. Exit code 0. There will actually it's an error here, but it is a fatal error here because we cannot display content of the pointer. Why it's not initialized? To avoid such a problem, the pointer value is it's not available here. The pointer value is. To avoid such a task, see what I'm going to do here. I'm going to say ptr equals var. I'm writing something here. It's wrong. It's wrong. But still, see, I'm just using the pointer to point to have the value of the var. It's an initialization, but it's wrong. Let me just compile. It's a clear fatal error here. It's actually indicated by this online compiler. To initialize a pointer based on the use of an existing variable, the pointer here, either we say that we are going to give to the content of this pointer the value of this var, the var. So to the content of this pointer, we do a star, and we run. It will give us the result. Here it has to give us actually normal. I don't know what, but it has to run. This is actually one of the indications. The second way, I'm going to just leave it here. I'm going to change it to a command. The second way is not like that, but to the pointer, we are pointing to the address of this variable, to the address. So here, the address. Compile again. It is working very fine with the same number. Also here it has to work the same way. So either we take to the content of the pointer the value we need, or the pointer points to an address, whatever the address we want. It is like that. The same way here, I may change this one to a command, and I may initialize the pointer to 0. ptr equals 0. Run. It's not given a value because 0 is not accepted. It's a fatal error here. We said that this morning. I'm going to change to a command also. The same issue also it would happen if I just initialize this pointer into null. The keyword null will indicate that it is from the IOStream library. It is initialized, yes, but it's null. So let's run. Still, it's not visible. It's a fatal error also. Error code is 0. So it's not accepted. It is an initialization, yes, but it is not for display. It is for process later on. Those two initializations, they are for process to utilize them here, not to give them actually to the output bring. After this initialization, for example, or this one, anyone, I can do this one here. Now I can do it, this one without error now, because earlier, see here, we cannot use this one to initialize the value without indicating an address. No, we cannot. So this one, I change only the order. See, I'm going to change the order here. Come on. Cut. Paste here. And I initialize this one with null or with 0. Whatever, it's okay. Good. So let me run. Still, I have to give it actually an address. I have to give it an address so to avoid this problem. So leave it like that. Sorry, just let me give it an address, and that's it. It's the address of this var, no more, no less. So I'll stop this explanation here. And this way we are reaching the end of this manipulation. Here's the question. Yes, the value of this address. So this way. Clearly here, the usage of the pointers specifies the. Just one another indication, actually, context of the addresses. those addresses, they are a question of your computer. They would be displayed based on your computer only. It's not a static value. Usually it's not a static value. It cannot be the same at every time. F8, E8, B8. It's not the same. It's not the same usually, because it's a space to be allocated based on this data type here. No more, no less. Task number 3. C++ program to initialize an integer variable. Reference the integer variable and display its value. Okay, great. New compiler, new interpretation interface. An integer variable, reference your variable and display its value. Okay, so simple. Int, let's say var, initialize variable equals 10. Okay, now just display it. Before I reference it, I'm going to display the content of the variable value is less than var less than an end of line. Great. So here, if we run, I have an error. What is that? Cout, the variable. Yes, exactly, because this cout is not recognized. So I have to call my namespace. Great. Still using name space spelling. Okay, the variable value is 10. The variable value is 10. We did not use any pointer, and the question is asking us to do what? To initialize an integer variable, reference your variable and display its value. That's great. I'm going to declare another pointer, another variable, sorry, other pointer here. I'm going to say p, and this p would be a star. Then after the p would accept the address of the var, the variable we declared earlier, and then after here I'm going to say we need to display the variable or the address. Well, let's do the thing. The referenced here, the referenced variable is $p. The referenced variable is the $p, the content of the p. Here I'm just making a reference to the address of the variable where it is located through this pointer here, and its content is being loaded, or let's say displayed, using the pointer p itself. This is the meaning of to reference a variable. So the value is in the var only. The p does not have any value, but it is referencing to the position of this variable. And when I ask to display its content, it would display the content of the var. Now I run 10. I'm going to change this 10 to, for example, 55, another number. Yes, it is automatically being updated. So the reference of this pointer is to the value, to the address where this variable is written. Whatever. So this way actually you are able to reference a variable. C++ program to initialize an integer variable, reference your variable and display its value. Yes, great, simple. Yes, the same way actually we did a reference, we may do actually a dereference. It's the same context here to display the content at an address. Nothing but displaying a content at an address. Yes, Zahra. A small modification I'm going to bring to this program here, the same program here. Instead of typing here, actually, because I'm dereferencing the pointer, because I'm displaying the content of the pointer, just I'm going to write p only, straightforward. So the reference, or the reference of the variable is p, and the dereferenced variable is the content of the variable itself. So here I'm just making a thing in a different way. The reference, as a reference, is the address where it is. And if I'm right here, if the program is correct, I'm gonna just call the address. The variable address is the @var. This @var here, it has to be the same as this one. Otherwise, there is an error. It is the same. It is the same. So this way we are referencing. This is the reference. And to dereference is to bring the output, the content of this one. What is it? It is the same value here. If we make the update, for example, here I'm going to change it to money value 150. This is the var, huh? Okay, run. It will give me the same out here in the pointer value, the pointer content. So this way, actually, we solve the task number here. Actually, this example, we are making the referen and dereferencing a variable here. Okay, in here, the var is referenced, and here the variable var is dereferenced. Okay, good, great. Yes, absolutely true. This is just to see the variable content and address. It's not from the question. Yes. Task number 5. Create a C++ program to initialize an array of 5 integers. Access your array using a pointer as integer and displays values. We did it earlier. Simple here. Okay, great. He said an array of 5 integers, so I'm gonna say AR not equal, but it's 5 positions. I'm gonna say. Okay, I'm gonna initialize the content here. Let's say 5, 6, 8, 9, 10. There are 5 positions here. They are initialized, and he's asking us to display the content of this array using a pointer. Simple. Cout. Here, the content of the array at I, let's say, or let's say at position, whatever the content of the array is. AR position 1 and so on, position 2 and so on. 5 here, starting from 0, 2, 3 and 4. Let me just display the content of the array is 5, the content of the array is 6, the content of array is 8 and so on. So it is like that. So I'm gonna bring an end of line everywhere here. Okay. Yeah, خلاص, it works very fine. Good. But it is not actually using a pointer here. I'm going to change this syntax here. Just I'm going to let me copy paste. Okay, the content of array. The pointed content, let's say here, content of array Okay, the pointer is not IR position 0. Here IR at the beginning, it's only the IR itself, so the first position, star IR. Position 1 plus 1, I close the parenthesis, I start the beginning the parenthesis, and before of that the content. The same thing here, position 2 plus 2, close, star and open. Here, star and open, plus 3, and I close my parenthesis. The same thing here, star and I open, plus 4, and I close my parenthesis. So here let me just run that. That's perfect. Positions here using the array, and then after the pointed, they are the same. They given us the output. So now using a pointer, we are displaying the content of an array. This is not the best way how to do that, because remember, if we have actually, for example, 50 elements, should we write them C out like this? No, it's not the best way. I'm going to just change something here. I'm going to just eliminate all. I need just one, and the same thing here, I need only one here, something like that. I'm going to refer to create a loop for, it's an int I that starts at 0 and is less than strict the size, which is 5 here, let's say 5, and this I is incremented by 1. Start curly brace and close the curly brace here. Good. Here at the position not 0 but I, here plus I, simple, plus I the position, or more or less 1, we will have the same result, but they are both of them 1 by 1 because we are inside the loop. Display 1, display 2, display 3, 4 and 5, both of them. So it works very fine, and this is the way how we manipulate the array as a pointer. Task number 6. Okay, we talk about the passing by value and passing by reference here. We did not discuss this one actually in theory, but just simply I'm gonna just give you a small introduction, and I'll stop there. I'm gonna do the same program here. So I'm gonna display the content of an array, something like that. But all of this activity, I'm gonna do it outside of the main. So here, I want to make the definition after the main definition here comes. So I'm going to say it's a procedure that have a void in return. Let's say disp array starts here and gets closed here. Good. This is the procedure. Okay. Great. And I'm going to just call this procedure. I'm going to just make the declaration first of all. Copy before the main. Here it is. Semicolon. And here I'm going to just make the call without the data type. Simple, semicolon. If I execute, same results. There is no problem at all. I'm changing the thing to be with a method only. The same output here is the same output for sure, but differently. The question said that we have to use a passing by reference variable or function declared to be called later on by passing by reference the value in order to finalize the same process. So to do so, here I'm going to say, I'm going to just declare an let's say a method that has actually a parameter. I'm going to say the same here, int, I'm going to say star p for example, and I'm going to call here the same disp, but it has to be with a pointer, something like that. Let's say ptr to change the name only. We have to declare it here inside the main. I'll come back. And the same thing here, I'm going to just declare the thing with an int, let's say p, which is a pointer. It has to be a pointer. And yes, here. And here, I'm not forced to say that I'm going to use a pointer because this is a declaration only. So simply make it easy. Just I'm going to declare that I'm referencing something only. It's an address. Let me check the errors here first of all before I continue. because there is a pointer I need to get it. So pointer was not declared here. I have to declare this one. So I'm going to say from the same data type, it's an int ptr that equals the null, and then after the ptr, it's enough. Let me whatever see what would tell me. Actually, it is null. Yes, exactly. I need to give it values. I'm gonna give int a. It's int a. It's an array. Size, let's say 5, and initialize to 25874. It's okay. Semicolon. Now the pointer ptr points to the a. Semicolon. That's it. And I'm passing this pointer. I'm pointing this pointer as a parameter to this array, no more no less. Warning: convert a non-pointer type int into form null. So no need for this initialization since I given the address. Still was not declared in this scope. The null is not required here. It's not the pointer. The pointer is required. Yes, still there are errors. Invalid conversion from int star 5 into an int, simple int. From a star into an int. Where it is. Yeah, here, because it's not a pointer. Is this a pointer? No, it's not. I missed the star. See the errors I'm fixing. Those messages you may face anytime. Good. Still errors they come here. Yes, here actually this asterisk here, this commercial and I do not need it. Still errors from a star to an int star. Let me just start them one by one. I know it's an argument. Actually, he's saying that is only one. Yeah, I know it's only one. We come back here. There is no, since it's an array, it's an array already. Minimize the errors. Okay. Let me pass to the third one. Conversion from int star to int. Yes, it's an int here. Yes, it's a pointer only. I know. Great. So here it's a pointer only. I'm passing the reference here, and it is. I'm gonna just pass the address, not the star. See, it is giving me that I cannot actually utilize such an expression because I'm passing a pointer here, no more, no less. Let me just use it as a pointer and full stop. Good. So the same output here, 5 5 here and here, 6 6 8 8 9 9. What are those? Those are actually the values here initialized already here in the array. Let me give a command as a title to this one. Actually, yes, pass by value, pass by address, or pass by value, whatever. We'll have the theory behind of this actually. Passing, calling methods, passing by ref, address, and value. We'll discuss them in details here, just to make you understand that you can pass things in memories as a reference only. So we'll discuss them in theory first of all, and then after we'll have more examples in next class. I'll stop the recording and just write